So in the previous video, I demoed this multi-sensor for home automation, which includes a DHT22 temperature humidity sensor, as well as an OLED screen for local display, and can be expanded with external sensors by connecting to a 3-pin header that I installed on the PCB. So today I'm going to show you how to make one of your own. So let's go over the parts required. Obviously you're going to need a power supply to power the sensor, and it's a very simple one with a mini USB connector. For this application, a 1 amp power supply is good enough. You're going to need the enclosure, for which I've posted a link to Thingiverse. You will also want this carrier board for the NodeMCU, which just ties the sensor and all its wiring together very nicely. You'll obviously want a NodeMCU board, the OLED screen, and there's two types of these. This is the 0.96 inch OLED screen, and there's two types, one with 4 pins and one with 6 pins. The 6-pin unit is for SPI, the 4-pin unit is for I2C. I prefer the 4-pin unit for I2C just because it's easier to put together. A DHT22 sensor without the PCB, just the bare sensor. A couple of 3-pin male headers, and a jumper switch. This jumper switch is for the NodeMCU board to select whether you're going to put 5 volts or 3.3 volts out on the external sensor line. So as you see, I already have my PCB pre-soldered with the female headers for the NodeMCU board, and that's just the way we finished it up in the NodeMCU PCB board overview video. So I will start by soldering the jumper header into the board, into the JP1 spot. And the header's on. Next, I'll put the second 3-pin header onto the EXT spot on the PCB. This is how external sensors will connect to the NodeMCU. Okay, next I'll slide this jumper switch onto the header, and in this case I'll just put it in the right hand side, so I'm selecting 3.3 volts for power to the sensor. Next, we will want to bend the sensor connector over to the side so it sticks out of the enclosure. But first, I prefer removing the plastic from the header pins, so I'll grab it with my cutters and just slide it off. And there it is. For bending the headers over, best thing to do is take a servo connector, slide it on fully, and then slowly bend it over all the way to the bottom. Slide it off, and we have the 3-pin EXT connector header pins pointed outside of the enclosure. The next thing we need to do is solder the DHT sensor onto the board. So, looking at the board from this side, I'll want to insert the DHT sensor into its spot on the board, lay it down upside down, just catch one of the pins with my solder. Okay, you really want to make sure that the DHT sensor is fully inserted into the PCB, there's no gaps, and it lays straight. This sensor will protrude out of the enclosure, so we want it to look good. Mine looks okay, so I'm going to go ahead and solder the rest of the pins in. And because the pins of the DHT connector are so long, I'll chop them off with my cutters. Okay, so we have fully populated PCB for the sensor, and now we need to connect the OLED screen to it. Before we get started, I prefer depinning the OLED screen and using solid hookup wire to connect the OLED to the PCB. So first I will cut the plastic holding the pins together. No need for that. And I'll need my helping hands for this. And one by one, I will remove the pins. Okay, now it's time to connect my screen to the PCB. So the way I have my code defined, I use D9 as the SDA line, and I use D10 as the clock line for I2C. And then I also have ground and 3.3 volts. Now, you'll have to be careful with the OLED screen because some of these have their pin order reversed. So in this case, I have ground, VCC, clock, data, but I've seen OLED screens which have VCC, ground, clock, data. So in my case, because we're going to these 4 pins right here, I'm going to take ground connected to the second pin. I'm going to take VCC connected to the first pin. I'll take clock, which for me is D10, and I'll connect it to the third pin. And I'll take data, which is D9, so I'll connect it to the fourth pin. Now, I like to use solid hookup wire for this because it's easier to solder into the holes on the OLED screen. If we look at the previous sensor, I'm using short pieces of wire about 2 inches. So I'll take a piece of red wire, green wire, blue wire, and black wire. I cut these off at different lengths, so I'm just gonna cut them all to the same length, and I'll strip off just a little bit of wire at each end. So first I'm going to attach these wires to the OLED screen side. So the first pin is ground, so I'm going to use the black wire. The second pin is VCC, so I'm going to use the red wire. The third pin, which is my clock line, I'll use the blue wire. And the fourth pin, which is my data line, I'll use a green wire. So my OLED screen is now soldered in, and now I need to solder it into the PCB. So once again, I'll use a NodeMCU as a template. First pin is 3.3 volts, so it's going to be my VCC, which is red line. Second one is black for the ground line. Third is blue for the clock line, and fourth is green for the data line. So I'm going to get all these in now. Okay. Next, with my connected OLED screen, first I'm going to remove the protective film, and I'm going to locate it on the pins that protrude from the base of the enclosure. Okay, make sure it's tight on there. It's all the way in. Should be sitting just a little bit inside the window here. And now that it's sitting in there, I'm going to use my soldering iron and melt down these little tips. And the OLED screen is now secured inside the enclosure. Okay, all that remains to do is put the NodeMCU onto the board and insert it into the enclosure. So you want to make sure, first of all, that these wires don't get in the way. Get them inside. Use your fingers to kind of guide the DHT sensor in and the PCB in. Make sure that the micro USB port comes out through that window, and then slowly slide it all into place. It should fit pretty snugly, but you should have access to the USB. You should see the 3 pins for the external connector, and the DHT should be sitting pretty even with the wall. And then we'll take our cover, and the cover should fit with these lines around the PCB. It should also fit pretty snugly, and you can use some tiny wood screws, number 2 or even smaller, in these 4 holes here to secure the cover to the enclosure. In this case, since I'm going to be doing more with the sensor later on, I'm going to leave them off. So that's it for part 1. We have built the sensor, and now we're ready to program it in Arduino. And that will be part 2 of this video series. So go ahead and subscribe to the channel, leave any comments in the section below, and if you like, watch some of these other videos and playlists on my channel. Thank you, and see you next time.